Welcome to TestingUy 2021. Thank you everyone for joining us today. Welcome Mesut, Durukal, and thank you for sharing your knowledge with the TestingUy community. We are very excited that you are joining us today in this testing packed week. Mesut, whenever you're ready, we are on board.
Okay, thanks so much, and hi everyone. I'm very glad to be a part of this amazing conference. And in this session, we are going to talk about some stories which were told to me by bugs. So first of all, they told me, and now I will tell them to you. We will discuss in detail. But first of all, let me briefly introduce myself. This is Mesut. I'm from Turkey, and I'm a QA engineer with 12 years experience, but currently I'm located and working in Japan, Tokyo. I'm working for Rapid Robotics, and in the robotics domain, I'm trying to implement some test cases to ensure the quality in our projects and in our products, and we are running them in our CI pipelines continuously, again, to ensure the development activities do not break anything in our product. And in this way, we are trying to continuously ensure the quality. Here you can find some contact information for me, some contact channels, so please do not hesitate to get connected or do not hesitate to reach out. And this is the brief agenda for the talk. As I told in the beginning, we will discuss about some stories and we will discuss about some ways to communicate to bugs. So if the bugs are talking, how we can communicate to them? And then what kind of information we can get from them? We will go over these questions. And finally, at the last part of the presentation, that last part of the talk, I will talk about the ways to utilize machine learning in our bug management activities. So during the information gathering process from the bugs, what kind of machine learning algorithms we can use to do these activities in more efficient ways. We will discuss all these questions and try to find some answers for them. So let's start with the first part. First of all, do bugs speak? And I'm saying that they speak. So what do I mean by when I say that bugs are speaking? I mean, they are trying to tell something to us. They are holding some valuable information. So they can tell some great stories to us, and they can tell some maybe warnings about the future activities, some future potential risks, or some they can give some clues about the weaknesses in the product, or maybe some improvement points in our processes as well, not only the product, but also the our handling way of the activities and the workflows. So they can tell lots of things to us. So they can talk. But of course, only if we listen to them. Because otherwise, maybe they will be talking, but only to themselves. Because we will not be listening to them. And we will not, if we do not try to understand what they are telling, what kind of valuable information they hold, then it means that they will not be talking to us. Because if we somehow open to get some information from them, if we try to understand and try to get some information from them, then talking to them is possible, because communication is normally two-way. We should be listening to them, and they should be holding and giving some information to us. So if possible, they can talk and we can get some valuable information from them. Okay, when I'm telling that they are sharing some stories, let me prove this by sharing some stories which were told by them. In my project, I listened some stories from them. For example, the first one was the story of an old ladybug. After a long and tiring root cause analysis, at the end of the study, we found out that the root cause was actually an already known issue. I mean, when we found the root cause, then we realized that this issue was already somehow raised some time ago. So the issue was standing over there. The ticket, the bug was open for a while, but it did not result yet. And eventually it resulted in some side effects, and we come up with this problem, with this situation finally. So when I went to this bug, when I visited this bug, she told me that, okay, I'm here for a long time, I'm open, and no one visited me before. If you came to me before, I would already warn you about these side effects, because I already know that there are some potential risks. Because this bug was not resolved until that time, because we make the prioritization and it did not have a high priority at that time. It's okay. Maybe if it is not very prior, then it means maybe we should not, or we don't have to resolve it immediately. But after listening to this story, what I understood is, at least even though we will not resolve it in the next few sprints, but still we can try to understand what kind of potential risks there are. And if we do not resolve this bug, what kind of other problems we can have? What was the root cause? And the same root cause can result in what kind of other situations? At least this we can get, this kind of information we can get from the bug. So even if we have some open bugs which are not resolved for a long time, at least we can visit them sometime and try to understand why they are not resolved yet. And what were the root cause for all of them? If there are any, even though they themselves are not high criticality bugs, if there are some other situations or issues which can arise from the same root cause, we can analyze these kind of studies and come up with some valuable information. Let me share you another story. Normally, it is called the sweet escape, because normally we are trying the bugs not to go in production environments. We are trying to keep them only in the testing environments or in-house environments. So if they somehow go to the production environment, to the customer sites, normally we don't want them to go there, because it is not a good practice to have some escape bugs in the customer environments, in the production environments, because it means that if we have some escape bugs, then it will be much more costly to fix them, because the code is already in the production environment. So if we try to apply some fixes, maybe it would be too late to change our code, which is already running in the deployment environment. But if we find them, detect them in the very early stages, like in our testing activities or development activities, then it would be much more easier to apply our fixes. So when I listen to the story of this escape bug, he explained me how he was able to go to production environment, which way he used to go to customer side. Because normally I thought that I closed all the ways going to customer side. But then when he explained me which way he used to go to that, then I understood there are some still open ways to go for bugs to the customer sites. So in the next iterations, I tried to close those ways as well. Because what he told me is, okay, I am covering some test scenarios. I am designing some test cases to cover the requirements or the use cases, but somehow if I execute them in a very limited environment, not covering all the environments which may be used by the customers, then it is likely to miss some bugs which can appear in other execution environments. So again, after listening to this story, which is told by this sweet bug, then I make some lessons learned and utilize them in the next iterations. In this way, reduce the number of escape bugs, which is the ultimate goal. minimizing the number of escape bugs which appear in the customer side in the production code. And finally, another story is told by a group of bugs. When we make some monitoring activities and try to understand try to gather some information from the bugs, we noticed that sometimes there are some group of bugs which are arising and appearing altogether and disappearing altogether, which means that some of the bugs are related to the same root cause. For example, if we are concentrated on improving the performance, like minimizing the usage of a workflow from the users, then we realize that if we somehow do not develop our documentation very well or in the proper way, then the end users, are having some difficulties to use these features. So for them, completing the workflows took more time. So somehow we understood that the documentation, the user manuals, and the completion of the workflows over user UIs are related. So if we are not managing our documentation tasks properly, then it will result in some performance issues. Like this, we noticed that some of the security bugs are arising altogether and disappearing altogether. For example, if we eliminate the issues over the gateways, all the security issues are gone. But if we have some weaknesses on the gateway or the authentication features, then we are having some security issues, a number of security issues. So these kind of relations between different groups of bugs were really useful information to utilize for us, because then whenever we notice some documentation, missing documentation tasks, then we would be already aware that we may have some other performance issues as well. So we are trying to get rid of these weaknesses as soon as possible. So listening to bugs can help us in two different ways. First of all, of course, we can learn about the weaknesses in our product, and we can get rid of them and improve the quality. And on the other hand, it may give some insights about the weaknesses in our processes. If there is some other way, some better ways to handle our workflows, then we can get these clues. For example, just I told recently, if there is a better way to do the documentation, then we can understand this from analyzing the bugs. We can understand that there is an improvement point in our documentation flow or some other flows. Then we can try to improve our processes as well. So monitoring bugs can help us to improve the product as well, improve the quality, and improve the processes as well on the other hand. But of course, to do it in the best way, to do it properly, our environment should be flexible enough to give the information. I mean, if our workflows or our environments are not visible and are not transparent enough, then we cannot get the relevant information. The life cycle of the bugs is just an example. But let's say if we do not have all the status showing the progress on the bugs, then we will not be able to understand on which status the bugs are recently, right? For example, if we put all the status on the trackment systems that we use, for example, if we are using Jira or some other issue trackment system, then we can customize the lifecycle of the bugs. So if we add all these custom fields, all the status, and if we add all the state transition diagrams, then we will be able to understand when the bug was created, and then when it was set to in progress, or if it was rejected, or if it was set as not a bug or duplicate, whatever it is, then we can read the comments on that and why this decision was made. We can understand all these progress. And whenever the bug was set into ready to test, we can understand when after what time the tester start to verify the fix. So we can also have this kind of information, how much time we are consuming on each state. For example, on the applying of the fix, how much time do we need? On the verification of the fix, how much time are we consuming? We can analyze all these kind of studies, and finally we can try to improve our processes. For example, after monitoring all the bugs, if we come up with the fact that we are consuming too much time on the verification of the fixes, it is staying in ready to test status for a very long time. It is not fully closed. If we understand this, then we can talk to QA teams and try to understand why they are not starting immediately right after they are set to ready to test. So this kind of information we can get, and we can do this kind of analysis. And eventually, if there is some points to improve, then we can go over them to improve our processes. So monitoring is really useful for lots of manners. But how can we do it continuously, periodically? Because if we try to do it manually, it is not easy. Each time I have to go to the issue tracking systems, I have to perform some queries, I have to get the answer from the server and try to understand the answer, response, try to parse the response. It is not easy. But what I can do is I can develop some code, automate these queries, and then run these queries periodically over code. Maybe I can put in a job in my CI/CD system, and then run each night, perform the query, get the answer, parse the response, and get the relevant information. If I get all the open issues from the server, then I can understand the creation time of the issues and the resolution time of the issues. So if I subtract one from the other one, then I can reach to the resolution duration, because I know the creation time, I know the resolution time. So the resolution duration can be found after getting this information. So automating the monitoring activities is one of the best practices. And the other one is, of course, usage of the dashboards. In most of the issue tracking systems like Jira, it is possible to add lots of dashboards and monitoring panels. Because numbers are great, numbers are holding lots of valuable information, but it is not easy to interpret what's going on only with the numbers. But if we somehow transform them into some fancy charts or monitoring graphs, it is way easier to understand what's going on. We can immediately see the distribution of different types or the trend over the charts. For example, if the numbers are going high or low in time, we can immediately see on the graphs. So visualization is a great opportunity to use. If we only try to go on with the numbers, it is not easy. So usage of the dashboards and graphs is another best practice. So talking to bugs is somehow possible. And if we try to listen to them, if we try to analyze them, what are trying to say to us, then we can get lots of information. But what kind of information we get? Let's go over this and try to find out some answers. I will show you some real cases, like some real lots of information monitoring activities that we have performed in our projects, just to give some insights about what kind of information can be collected from them. So we can do this in two different ways. Maybe we can collect some bugs which are opened or somehow processed in the current sprint. This is one way. Or we can have the bugs from the start of the project until that time. This is getting the information in the cumulative way. So I will show some examples from both of them. So let's start going some examples one by one. The first one that we used in our project and which was very useful is the distribution of the bugs according to their status or severity. For example, we were using what percentage of the bugs are still in open status and what percentage are in progress and what percentage in verified or closed. And of course, doing this according to the severity levels is very important. I mean, for example, for the high severity bugs, if we still do not have a high percentage of progress, most of them are still in open status, not in progress yet, then we were having an action item. We try to understand why the high severity bugs are not started to be resolved yet. What are the blockers for that? What are the impediments? So if we find out that there are some blockers to start for the fixes, then first of all, we try to get rid of those blockers or impediments. In this way, we can, whenever we see the number of open bugs for the high severity ones, then we were listing them, and for all of them, showing and seeing the impediments and trying to get rid of them. Another one is the distribution of bugs on which feature they were found. For example, for our system, the system was composed of lots of microservices and services. So what we have done is we listed and make the distribution of bugs across on which feature they were found. For example, on the asset management service, they were found, or on event management service, they were found. So in each sprint, we were doing this. And if somehow we realize that most of the bugs are arising from a certain service, then we were trying to understand what's wrong with that service, because obviously there is something wrong, right? For example, if we have 20 services and half of the bugs are arising from only one of them, then we can estimate that there is something really wrong with that specific service, because the distribution is not homogeneous and most of them are somehow heaping together on a particular service. So maybe the deployment was not done properly, or maybe some simple step was missed for that service. So it really give a great insight to solve the issues very quickly. And in this way, we were able to understand which service is more open to some bugs, which were more flaky. For example, if after monitoring these distributions, if we see that some services are stable, I mean, they have some bugs like in a in a range which can be estimated, like maybe each sprint 2 bugs, 3 bugs. But if on the other way, if some other services have bugs, for example, this sprint 2 bugs, then the next sprint 20 bugs, and then again 3 bugs, and then again 30 bugs. It means that the service is not kind of stable, but maybe flaky or fragile. So we were, if we realized this, then we were having some action items and try to understand what was resulting in this flakiness. Another type of monitoring that we have done is showing the distribution of bugs according to their types. For example, they were found after the functional testing activities or performance testing activities or whatever testing type resulted in these found bugs. So in this way, again, we were able to understand if something was missed in the development activities regarding these types, like some performance improvement activities are missed or documentation is missed. So we were trying to get some insights about different development activity types. In addition to all these distributions, of course, we were having some progress charts, like in what pace we were finding the bugs, or we were resolving the bugs, and additionally, the gap between the created and the resolved bugs. So if we realize that somehow the gap is increasing in time, then maybe what we would do is a little bit slow down the development activities because the gap is increasing more and more. So maybe it is time to a little bit slow down the development activities and concentrate more on the bug resolution. So we could have these kind of action items as well. And finally, in addition to the charts and the trend graphs, we can have some tables as well, showing a different status distribution among different types or severity levels. For example, again, related to the one story which I told about the age of a bug, then in this way, if we saw these kind of tables, we can understand if there is a very old bug which is open for a very long time in the high severity level. Maybe for the low severity levels, as I told, maybe it's okay not to solve it immediately, but at least we can try to understand what is the root cause and what are the potential problems which can appear in the future. But at least we can have this information and be careful about the potential risks and threats. And of course, we may have some other tables as well, but especially what we were concentrated on was, one of the things was the escape bugs. As I a little bit mentioned in the beginning of the talk, it is not desired to have some escape bugs, because normally the intention is to find the bugs as much as in the early stages, because it will be much more difficult and costly to try to fix them in the production environment. So we were monitoring the bugs which were found in the production environments as well, because the customers will be using some different scenarios, right? They will not be using the product in the same way that we are using it. Because we will be, as the testers and the developers, we will be already experts using these features and the product. But for the customers or the end users, for the clients, it is not the same case. They will be using for the first time. So they will try some other ways, and most probably they will fail. So we should be aware of this risk, and we should be careful about the escape bugs which can appear in their sites and their scenarios. So finally, in the last section, I will share some studies, some case studies, showing by how we can utilize or adapt machine learning algorithms into these studies. Because by machine learning algorithms, we can perform some bug classification activities or bug clustering activities. For example, normally we are assigning bugs to some people, right, for the resolution. If we are making the assignment not correctly, then we will waste some time. The person will reject, it is not my responsibility, you should do the assignment again. So we will lose some time. So making the assignment correctly is very important. Or the bug triage is again very essential, because we are from the start, we are always talking about the prioritization and the severity levels. So if I somehow mark one of the bugs as low severity, whenever it should be high severity, then it means that maybe I will postpone the resolution. So it is very essential to decide about the priority in the proper way. But please think about it. In our projects, there are lots of colleagues and teammates, right? Everyone is not deciding in the same way. I mean, sometimes for me, it is high severity, but for someone else in the project, it's not high severity. So there may be some inconsistencies, because it depends on the person who is doing the bug triage. So what I'm trying to say is, if we somehow are able to do it with the machine learning algorithm, it will be much more consistent, because the algorithm will review all the past samples as well, and try to understand how the decision is made. For example, like a certain type of bugs in the past samples, it was generally set to high severity. Then for the upcoming sample, the algorithm will understand that it should also be set to high severity. The machine can do this, can review all the past samples. But for us, for people, it's not easy. For example, whenever I'm raising a bug, I do not check all the past bugs which were already created in the project. For me, it is not possible. I don't have too much time to do that. But for a machine, it can be done. This analysis can be done in seconds. So the result can be much more consistent. So what I tried in my project is I tried to classify all the bugs according to severity levels and try to estimate the priority level of an upcoming bug. For example, after I generate a model due to the past samples which were already created in the project, and then whenever I create a new bug, it recommends the severity level for me using the generated model. So in this project, the data that I used is there were almost 900 tickets get from the Jira, and there were 6 severity levels, but 2 of them were actually not bugs, but kind of change requests. So there were 4 severity levels, and one of them was not there in the system because normally it is created for the bugs, which is regarding the health issues, like safety issues. And in our real project, we did not have that severity level. So in fact, we had 3 different levels. So I tried to classify the bugs to one of these 3 classes. So let's see the results, how it worked. So first of all, of course, the bugs are written in text in some strings. Like I'm raising the bug by defining some texts. So first of all, I have to generate some numeric numbers, some vectors from these. So I used different methods like the bag of words, which is vectorizing these string values into some numeric vectors, and then extracting some features from the bugs. After the feature extraction, I made the classification. I used lots of different algorithms like SVM, support vector machines, or some decision trees. And finally, I decided for the best performing one. So in the first round, I tried to classify among these 3 classes, but please be aware, seeing on this distribution, class 2 samples are dominating the others. There's a bias to decide on the class 2. So the results were like this one. The confusion matrix is tending to predict all the results to class 2, and the overall accuracy was 73%. When I test this performance of the algorithm over the already known bugs, then 73 were predicted with the same priority level marked in the real bug. It is okay, it is not very bad, but due to the bias that I just mentioned, it can be improved. So what I've done in the next round is I combined 3 and 4 together. Why? Why am I doing this? Because it makes sense for us in our project. If the bugs are having class 2, severity level 2, then they were regarded as the release blockers. But if they are either in 3 or 4, they are not release blockers. So deciding if they are belonging to class 2 or not was an important decision for us. So I tried to, in this round, I tried to classify bugs to belonging to either class 2 or not, which means 3 or 4. So in this way, it is much more balanced, as we can see. So the confusion matrix looks like this, which is likely to give some better results. And the overall accuracy was 82%, which is more acceptable. So I'm close to the end of the talk. So let me summarize what we have discussed throughout the whole discussion. So first of all, we discussed that bugs are talking, which means they are likely to tell some stories to us if we listen to them, which means if we try to analyze them, try to understand, try to interpret what they are trying to tell to us, what kind of information they are holding us. And then we went over lots of different distribution charts and trends showing different numbers and progress. And finally, in the last stage, we discussed how we can utilize machine learning algorithms to do in a much consistent way and an easier way, faster way to do these kind of activities. So now, if there are any questions, I will be more than glad to try to answer them.
Thank you, Mesut. It was a great talk. So there is a question or an observation from Gustavo that he saw that the amount of non-categorized bugs was significant. I mean, in the graphs that you were sharing with us in the middle of the presentation. So I don't know if it would be fine or if it would be useful to distribute that through different categories, or is it okay to have like a huge other category?
Actually, these classification activities are most of the time very useful. For example, now what we are trying to do is trying to classify them according to like the phase they are found, if they are found in the internal activities or in the external activities, or try to understand the root cause of the bug, like if they are stemming from the misunderstanding of the requirements, or an implementation issue, or a testing mistake, or whatever. And all the other classifications, like the visibility of the bug and the impact of the bug. So according to these two, the visibility, the likeliness, and the impact, we are deciding to the priority of the bug, and lots of other classifications we are doing. So from time to time, we are getting some insights from them. They are really useful. So yeah, if we realize that most of them are not categorized yet, then we can go over all of them and wrap them up with some different categories.
Okay, perfect. Thank you, Mesut. Okay, while attendees are thinking, I would like to ask you about different teams. I mean, I faced in different situations that the team is not very pro or confident to use to report defects whenever they are popping up. How do you convince them, or how do you handle those situations where the team is not convinced that reporting bugs is important to make this kind of analysis? Because sometimes it could happen that the developer solved the issues in the fly, so there isn't any track. And well, what would you suggest on those situations?
Yeah, it is happening. For example, the developer sits next to me, so maybe I can directly tell to him, and then he can directly solve. So we can do that. But I think we should raise the issue, because we need the track. We need all the analysis. Because maybe if it is solved on the fly, then maybe we will have it in the regression in the next cycle, right? So if we had the ticket already, then we can refer to them. Because not only raising the issue, I think we can put lots of information inside as much as possible, like the linking the PR, making the fix, and after the root cause analysis, putting the information regarding the root cause. Then if we have this issue again in one of the next regression cycles, then we can refer to that ticket which was raised before. And it will be much more faster to understand the root cause, because it is already there. But otherwise, if we have no ticket, then the root cause should be performed again from scratch. So it's a waste of time. So even if it is a very simple thing, in my opinion, we should raise the ticket.
Okay, thank you. Yeah, it's very important in the midterm for analysis. Okay. Okay, Gustavo is. I like your approach, Mesut. Thanks. So, for your answer. And well, here Agustin is asking, do you have any tools, suggestions when it comes to incorporating machine learning analysis, for example, the Jira?
Yeah. For example, when we get the information from Jira, you can export it to some spreadsheet, like an Excel form. So there are categorized data already if you get from Jira. So you can study on this data. Like what I did is I tried to classify the bugs according to their summary fields. For example, when we are raising a bug, we are writing the title and then filling the summary field, like describing the situation. And then we are setting the other fields like the severity or the assignee or whatever. So I tried to categorize according to their summaries. For example, it is working like if most of the bugs having the not working key, for example, keyword, if they are set into high priority, then the machine understands, okay, if in the feature samples, if there is the not working keyword, then it will be most probably a high priority. So it works like that. Try to understand the general hidden patterns. And to do that, what kind of tools or suggestions we can use? Of course, it depends on our case. For example, what I did is, as I told, I tried different algorithms like support vector machines, decision trees. There are some libraries written in Python to try that. It is very simple. You just import the library and call the SVM method or a decision trees method. It's only a few lines of code. It is very simple. So the issue is just to get the libraries written in Python. And most of the machine learning algorithms are prepared. Libraries are prepared in Python language. So I recommend using that. And you can try all the algorithms and see which is performing in the best way. Then you can go with that particular algorithm.
Okay. Thank you, Mesut. And while the people is still thinking, how many items did you use to train your model of machine learning?
Yeah, normally in machine learning, having a wide range of data is very important, because otherwise, if the data set is very small, then the model cannot be constructed very well. It will not be covering all the data range. But I tried to use the real data, not dummy data. So in my case, the data set was kind of small. There were like 900 bugs created in the real environment, but not too much, as I told.
Okay, thank you.
And maybe in the meantime, I can add some further comments on your question about reporting the bugs. I think like the other aspects of the being a software tester, sometimes it requires a great soft skills. You should be really good at communication, because you have to manage this communication, right? You are raising some bugs, and sometimes I guess most of the people will realize that or recall that sometimes the developer or the product owner, whoever, will reject. He will say, okay, it's not a bug, it's a feature. But maybe you are still believing that it is a bug. So in this kind of cases, it is very important to manage the situation well, because we should not be rude, but in the meantime, we should support our ideas. We should be insisting that it is a bug, because we are the advocates of the quality. We should support our claims. So in the meantime, you should stand strong behind your ideas. And in the meantime, you should not be mean or rude to anyone. So it is kind of a balance, trying to build a good communication channel.
Nice, good suggestion. Okay, so no more questions are coming up. Thank you very much, Mesut. Very clear from Karina.
Thank you. Thanks for the attention.
And well, thank you all for your time. Again, thank you, Mesut, for sharing your knowledge with us. It's very, very late in Japan, so we appreciate a lot that you were joining us. And well, see you in the next TestingUy activity. So thank you very much again, and see you later.
Thank you. It was my pleasure. Thanks for the great organization and moderation.
Thank you, Mesut. See you.
See you.